Welcome to the office. We want to take a look at another theorem from section 4. So this is theorem 4.17 from our text. Let's see here. In G, so we have, maybe it should say if. I think it actually uses the word in, but anyway, if G is a group of binary operations star. Excellent. There is only one element E such that that's the identity. Likewise, for each element A, there's only one inverse element. Okay, so the identity and the inverse for each element are unique. So we already know that the identity is unique. This is a result, right? The uniqueness of the identity is a result from section 2. It did not require that we have a group at all. We just needed to have a binary operation. If there is an identity for a binary structure, then it is unique. We already proved that. So that's not something that we have to prove here. What we do need to prove, however, right, we should comment, of course, that we already proved the uniqueness of identity, but what we do need to prove is the uniqueness of the inverse, which is pretty straightforward. So I want to write a short proof of that. Let G star be a group and let A belong to the group with inverse A prime in G. Okay, so with some inverse. Suppose B prime is also, let's just call it B. Suppose B is also an inverse of A. Then A star B equals B star A equals E. Since A prime is an inverse, this is where we do rough drafts and final drafts. I should have written this up here when I specified that A prime is an inverse. But since A prime is an inverse, we also have that A star A prime is equal to A prime star A, which is also equal to E. Then, right, I can just use this guy and that guy. They're both equal to E, so by transitivity of the equality, we have B star A is equal to A prime star A. Now, this seems really silly, but I can use the inverse. Or essentially what I can do is I can recognize right cancellation law. The right cancellation law holds. So I immediately get that B is equal to A. That's the right cancellation law. So I get the right cancellation law, which gives me that B is equal to A. I'm sorry, I'm missing my prime there. B is equal to A prime. Fantastic. Thus, the inverse is unique. And that's all that I wanted to show. I already know that the identity is unique. We could also give a proof of that if we wanted to. All right, that's it for that theorem. So I'll see you guys back here in the office for our last theorem that's actually a corollary. But I'll see you in the office in just a moment.